Hello everyone and welcome back to another mini concept regarding physics, this time about free body diagrams. So what are free body diagrams? As you can see on the screen, we have one already set up. A free body diagram is a 2D representation of forces acting on an object. So this allows us to visualize why an object is moving, or if the forces on it are balanced, therefore the object is at rest. And we also get to imagine what would happen to an object once a force is applied. So there are three parts of a free body diagram. There is the object itself, there is the forces acting on an object, and there's also the surface or rope that the object is hanging on. In this case, since there's a box sitting on a table, the surface is going to be the table. And in other situations, you'd be able to see a rope, particularly regarding tension problems, since tension describes the force of an object, force being exerted on an object by a rope, or to hang on to a rope. So now let's talk about how we're going to be able to give our forces here in this free body diagram magnitude. So as you can see here, we can see that there's an object and there are forces acting on an object. However, there is no magnitude. Now we have to determine first, are these forces balanced? Seeing that the object is at rest, we'll describe this as at rest. Okay, that means there's only one force acting on the object, which is gravity or weight. It's mass times the acceleration due to gravity. So weight is the only working force here. And weight is described as mass times gravity. And for gravity, we'll just be using 10 meters per second squared to make things simpler. So in this situation now, all we're going to do is we're going to get our mass, which is 1 kilogram, and then we'll multiply it by 10, which will give us 10 kilogram meter per second squared, or simply 10 newtons. So now we have a value for our downward vector. We can actually make this negative because it's going down. And since according to the third law, for every action there's an equal and opposite reaction, the normal force on top, which is again the returning force, let's say, of a surface on an object, that has to be equal and opposite, so we'll just have 10 newtons that is positive. So since these two sum up to 0, that means the object is in equilibrium and therefore at rest. So we'll cover more about this topic and different situations regarding free body diagrams in the next video, which is our in-depth topic. I hope you guys won't miss that because this topic is actually really crucial for a lot of different physics situations, especially about dynamics. So thank you everyone, and I hope you guys learned a lot. I'll cover more in the next video, so yeah. Bye everyone, and thank you.